Restart.
Restart.
No Mountain Dew.
No Mountain Dew, that's right, exactly. All right, now that we have it started, let's go ahead and open up a new tab, and we'll do this. We'll do exactly what the note said. I'm going to use an ls command. Can anyone remind me what this command does?
List service.
List, exactly. It shows you what files are in a particular folder. If I just type ls and then press the enter key, it shows the files in the current folder. But if I use ls and a path, it will either show the content in a directory or it will show that whether a file does exist or not. So in this case, init.d is a directory. As a general rule, in Linux, at least in modern Linux, if a name ends with .d, it is typically a directory. Okay, the .d kind of signifies that it is a directory. Do extensions mean anything in Linux? Absolutely nothing. So it's a convention more intended for end users to realize this is a directory instead of a file than for the system to understand this is a directory. Okay? And this is running off of the live DVD, and it has all these surfaces already. Some of these are, as the name implies, it does certain things, and others are kind of like, what does that do? Okay? So let me just kind of go ahead and talk about a few of these. I'm not going to talk about all of these. One that we know for sure that we should know what it is now is GDM3, which stands for GNOME Display Manager version 3. Okay, so this particular script is just a script. You can actually type it out. It's just a text file. It's a script that allows you to start and also to stop and also inquire the status of the GNOME Display Manager. So you can stop the Display Manager if you want to. You can restart it if you want to. You can also ask, is it running? Okay, it's a service. What else? Networking. Okay, this is also a script. It's a script where you can basically stop networking resources like using one single command. If you type as root, if you type /etc/init.d/networking space stop and then press the enter key, it will shut down all the networking resources. It will just basically turn off your NICs. So you will lose networking completely when you do that. Post audio, this is a surface that relates to the audio of the system. And this combined with ALSA utils, they work together to provide audio services. We have SSH. Does anyone know what SSH is? Secure shell. Now that name is very misleading because it makes people think, oh, so it's just a more secure version of Telnet. But it is a lot more than that. Okay? In this class, we may or may not talk about SSH in depth, but SSH as a protocol is not really just for telnetting into another system so that you can run commands through the command line interface. You can transfer files because SFTP or SCP are sub-protocols of the SSH protocol. Okay, so you can use remote shell, you can also transfer files. But that is not even scratching the surface of what SSH can do, because you can also tunnel. Okay, now this is not a networking class and it's not a server class, so we are not going to talk too much about SSH and its really super duper capabilities in terms of doing tunneling or forwarding X traffic and so on and so forth. But it's a very interesting service. It can be very useful, especially when you want to remote access a system, but not really just using the CLI, the command line interface, but also want to run the GUI. Does everybody know what is VNC?
VNC?
VNC stands for. Sorry?
Very new cable?
No. All right. Well, you guys all have computers in front of you.
Virtual network client?
Yep. Well, no. VNC stands for Virtual Network Computing. It's kind of like a remote desktop kind of thing, except it's cross-platform. But it's not by itself. VNC can be an insecure protocol. But if you tunnel VNC traffic through SSH, then everything is going to be encrypted. And to the network administrator of a system, it looks like one single connection. Because the SSH connection with one single connection can be used as a tunnel for many, many other protocols to go through. So you can have 20 protocols being forwarded back and forth between two computers, but to a network administrator, it only looks like one port 22 connection. All right. Are we still doing okay so far with these concepts? Stop me as soon as you have questions. Okay, so let's take a look at something else. Let's take a look at this one. What is Samba?
Web server?
No, it's not web server.
It's like Active Directory.
Nope.
Windows file sharing.
Windows file sharing, otherwise known as SMB, and that's why it's called Samba. Okay? So this is an important one. If you want your client computer to be able to talk to other Windows computers and share files, you need Samba to be up and running. But when Samba is up and running, it will also return, or it will respond to other computers saying, hey, are you there? Is there anything you want to share? So this is one of those surfaces where you really have to be careful about what it is going to respond to, and what files you are sharing with people who are asking, hey, this particular computer, do you have anything to share? That's Samba. Let's take a look at some of the not so obvious ones. Let's see, we have this one here, MD-ADM. How cryptic can it be? MD-ADM is a software RAID service. In other words, you can use this to start up a software RAID subsystem, or you can stop it. Does everybody know what I'm talking about? What is RAID?
Yeah.
RAID? Redundant array, and my version is always inexpensive drives. I think that's the original definition. Later on, they changed the I to something else. What did they change it to?
Integrated.
Integrated, independent. Yeah, but I think the original version was inexpensive, because before RAID, in order to have redundancy, you have to have a lot of money. So in this case, MD-ADM is a service. Okay. In other words, when you start up the service, it will automatically go through all the connected hard drives and see whether you have a software RAID system already attached to the system. And if there is, it will start it up, and then you will start to see those drive letters appearing as /DEV/MD10123 and so on. When you stop, what happens to those special devices? They all go away. So that's a service. You can basically, these are components of your operating system that you can start or stop at any, well, I wouldn't say at any particular time, but you do have some control over whether to start or stop it. We'll go over one more, and then we'll continue with the rest. rsyslog, can anyone guess what it is? What kind of a service is syslog?
System log.
System log, okay. Now, system log seems like a pretty simple concept, right? You just want some programs to be able to write to a file in /var/log, and then just, everything you spew out, will be logged into a file.
Would the RB the read for
Message?
Hmm?
Log message?
Say again?
Log message for the messages?
Yep, log messages, but it can be any type of log message, okay? So, okay, here's the situation. You have one single /var/log/syslog file, but you have tons of programs that are running, and each one can potentially want to write something to the syslog file, okay? So do you want all of these programs to attempt to append something to that file uncoordinated? Or do you want somebody to be sitting in front of the actual syslog file and say, okay, I'll be the manager. Okay, if you guys want to put something into the syslog file, talk to me. I'll do the coordination. Which way do you want it to be? Do you want everybody to have access to the syslog file? You want a coordinator, right? A single process that is responsible to coordinate everybody who wants to put something into the syslog file. Because if you don't, what's going to happen?
It's hard for you to monitor.
Well, what if two processes want to write to syslog at the same time?
To be confused for the other PC or for the other system.
Well, the problem is, it's possible for one process, which is a program in execution, to put something into syslog, and then the operating system decides to let another process to write something else. In other words, the messages can be interleaved, and then it's garbled. Okay. In the end, you have the right number of characters written to the file, but the order is going to be interleaved. It becomes almost impossible to read the original message. But when you have syslog as a system service, then everybody who wants to put something into syslog has to go to a particular process and say, hey, manager of syslog, I want to put an entry into the syslog file. And then that process will, in the end, do all the coordination. Okay? You try to talk to me first, I will write your entire line to the file before I process the next request. So that's why syslog itself is offered as a service, and not, everyone can write to the file at the same time. Are we doing okay so far with the concept of what a service is in its broad definition? Not its narrow definition, but in its broad definition. Is that okay? But are you convinced that even with a client system that is not intended as a web server or a database server or a file server, you still have a lot of services? The system still needs all these components to function correctly. Are we doing okay so far? Okay, next question. Would syslog ever become a security issue? Potentially, and that's because it may be logged in something that is that has sensitive information. But can someone attack through syslog, the syslog daemon or the surface that's dealing with syslog from the outside?
I don't think so.
No, it cannot. Well, it is a service, which means other processes has to talk to this particular program through some kind of an interface. But fortunately, that interface does not map to your network part. In other words, syslog can only answer requests from processes of the same computer, local to the same computer. It never responds, or if properly configured, it never responds to requests coming from the network. Is that making any sense? So if you go back to the notes, there's another way to find out what services are active at any particular time. And this command is a little bit longer. It's PS, which lists all the processes. In this case, -AF is case sensitive. Everything is case sensitive. It has to be uppercase A for all, and then F is a particular format. And then --forest is interesting because it will use text to represent a tree structure so that you can see which process is the parent process of which other process. So what I'll do is I'm going to run this command. You don't have to do it, so you can just kind of focus on the projection screen. Okay. And then the vertical bar after that is a pipe operator or pipe symbol, and then we have a second command called less. Did Michael talk about the concept of pipe and how do you use the concept of pipe to string commands together? Sort of? Yes? No? Yeah. Okay. I'll just do a very quick review of what a pipe is. If I just run the first command, which is the PS command, it will spew out stuff so quickly that I cannot really read everything. I can use the scroll bar in a terminal to go back up and down, but eventually that can also run out of buffer space. Okay, it is possible to scroll out of the buffer allocated to a dumb terminal. So it makes it really hard to look at the output of a program. What the pipe symbol is doing is it's taking the output of the first command, which is the PS command, and it says, okay, I'll take your output and make it the input into the second program, which is the less program. The less program is what we call a pager. A pager takes in a huge text input file, and then it allows you to use page up, page down, so that you can go from page 1, page down, display page 2. You can also scroll line by line. but it also offers some additional features, like you can search for particular patterns. You can search for regular expression patterns. So that makes it easy to locate specific patterns within the text that you're displaying. So we'll go ahead and run this command. And this is the result of running the command. Now, in this table, we have a few columns. The first column is called UID, which stands for user ID. User ID, as the name implies, is usually a number, but it is now represented as text so that we can easily tell which user is the owner of a particular process. The second one is PID. PID stands for process ID. A process, if you remember from last week, is a program that is being executed. So that's for each instance of a program that is executing, it has an ID, which is just a number allocated to that process. So this way we can designate a particular process if we need to. PPID is the parent process ID, because in Linux, when the system starts up, there's only one single process. There's only one single program in execution, which is the kernel. But eventually, we have all these different processes running at the same time. The parent process that creates the other process is called the, well, I just use the name parent process. And this displays which process is started up by which one. It's telling you that the process corresponding to number 2 is started by the process with an ID of 0, which is the very first process. These numbers are sequential. In other words, these numbers typically will tell you the order of the creation of these processes. Can you see that K thread D is the parent of a lot of these other ones? Right? Do you ever run these programs, by hand on a command line interface? No. Do you ever interact with these by hand? So these are all surfaces. They're all running in the background, waiting for something to ask it to do something. So when you scroll down, we have a lot of these names, and some of these are not the actual process name. They are actually modified already. And then we can see, these two daemons here. This is MBD and this is SMB. Both of these are used to implement the Windows share services. We have Getty to implement teletype dumb terminal lines, serial lines. And so this is one way to identify all the processes that are running. And for anything that has a parent process ID of 2, those are all basically surfaces. So this is another way to find out, what surfaces are running in your system. Well, there's a lot, but which one actually pose any type of security risk? This doesn't tell you. And okay, so we'll talk about how you can tell which process can be a security risk. How many people have heard of this term, a daemon? Is it pronounced daemon or demon? I think it's just daemon. A daemon is basically a surface, from our perspective, but it's a specific program that implements a particular function. Typically in Linux, if a program ends with a letter D, is a daemon. Okay, so if you're running SSH as a surface, then SSHD is the daemon that is being run in the background to provide the surface of SSH. And the same thing with FTP. If you want FTP as a surface, FTPD would be the name of a daemon. Same thing with Telnet. Telnet is the surface. Telnet D is the daemon. Are there any questions at this point? So at this point, there are different ways to find out what kind of surfaces we have in a system, potentially and also running. But we have no way to tell which one we should potentially shut down because of security risks. Question? So the next article, which is really, really short, talks about a particular command called netstat, and this is really interesting because assuming a surface is network-based and is TCP/IP-based, which is pretty universal, you can find out which process is listening to which port using this command here. I'll run this command, but you should run it as root. So I will have to change to my root user first, and then run the command. And netstat -tlnp, and then pipe it to less. Well, that's not a whole lot because this is a fairly secure client system. Now, when you look at this output, I think it's probably best to make the screen wider because they're not just missing one column. Okay, there we go. That's good. This column tells me what type of protocol we are talking about. It's mostly one of the two. It's either TCP or TCP version 6. If it's not, TCP 6 is actually just TCP version 4. Okay. So that tells you about the protocol. The Q part is not as important in this case, but it is important to know what is the local address. When you look at this one here, the local address is 0.0.0.0. It is corresponding to all possible interfaces. Okay, right here, right now, we have to take a little bit of a moment to stop and explain what is an interface in terms of networking. Can anyone give me a quick answer? What is an interface? Okay, let me change the question a little bit. How many network interfaces can a computer have? A host? No. It can be any number. It can be 0, meaning your computer has no network ports whatsoever. It can be 1, it can be 2, it can be 50, it can be more than that.
Could be 1,000.
It can be 1,000 if you want to. And the interface does not even relate to the actual network card. In other words, you can have one single NIC, but you can still have many interfaces, many IP addresses corresponding to that interface. Okay? But 0.0.0.0 is kind of special. I'll explain that later. This is the port number. Port 139 is the port number. Sorry?
139 is the port for the SMT, right?
Yes. That's the port number.
The port number.
But it's the port number of what this program is listening to, and this is the process ID. 3207 in this case is the process ID. So the process with the process ID of 3207 was started by the command called SMBD, and it's listening to port 139 from all interfaces, not just the local host loopback interface. If you have 3 NICs, they're all active at the same time, it's listening to all network interfaces. Okay? So you have to pay attention. When you see 0.0.0.0 as the local address, as the interface IP address, you have to be very careful because it's saying, I'm listening to all the network ports, all the network interfaces. Okay? So potentially that can be dangerous. Same thing applies to SSHD here, the second line. SSHD, as the name implies, is a daemon, and it's offering service through the SSH protocol. The process ID is 2847. If you want to kill the process, you just say kill space 2847 in this case. And once again, it is listening to the IP address that it's listening to, or the interface is 0.0.0.0, which means it's listening to every possible network interface that you have. If your computer is internet connected with no firewall in between, anyone can send a request to that port, and your computer will respond to it. Are there any questions? So that means you have to be careful. What about the next one? What about this one here, which is cups? That's a print surface. It has a different interface address. The port number is 631, which is easy. But what about the IP address. What is this special IP address 127.0.0.1?
But your own
Still
address.
use that.
It's your local host, okay? It does not actually map to any actual
Not
name.
listening for anything outside.
Correct?
It's not listening for anything outside.
It is not connected to the outside. In other words, anything that connects to 127.0.0.1 port 631 has to come from the computer itself. The process, the client process, has to be on the same machine as the server process. So it cannot be used for an attack that's launched from the outside. So this one is safe, okay? This is safe. The next one is once again not safe, but it's not surprising because it is also coming from the same daemon. In other words, you can have one single process. In this case, the process with the ID of 3207 can listen to more than one port at the same time. That's perfectly fine, okay? A process can listen to as many ports as it wants to. Are there any questions at this point? So my security concern at this point will be this particular program, SMBD, and also this particular program, SSHD. This is not as much of a security concern because it is not open to anyone who's outside of this computer. Are we doing okay so far with identifying what can potentially be a problem? Yep. Yes or no? Okay, very good. What kind of bad things can happen with SSH? This computer is ready to accept connections through SSH.
You lose the keys.
Yep. Well, since this is coming from a live DVD that has a default password, that means you guys can all log into this computer and gain access, at least at the command line level. The next question is, can you log in as root?
Yeah.
If I have
Well,
a-
That depends on how SSH is configured. The SSHD, the server, allows you to configure it so that you can only log in as a non-root user, which is a good idea. If you ever have to configure a computer and offer SSH as a service because you might need to log back into the same system, always do not allow root access. Why not? What difference does it make?
a big difference.
What kind of big difference are we talking about? Yep.
Everybody knows. No, everybody knows.
Yep, because everybody knows that root or admin, those are popular names to try to hack into. Now, if they don't know, if you do not allow logging in as root, the first thing they do have to guess is, what is a valid username? Well, that's already one obstacle, right? It's one hurdle already. With a live DVD, it's easy, it's just user, right? But on the actual real installed system, it's not as easy to guess a particular username. So you already have one automatic protection against dictionary attacks, because they have to get both the username and the password correct in order to get in. And when they do get in, they're only coming in as an end user and not as your root user. If you keep the ability to be able to log in as root, then the first thing is your system becomes much more susceptible to a dictionary attack because root is already a username. They know the username does exist. And then two, it's just a matter of looking up a dictionary to try to hack into your system. Once they hack into your system, they automatically have root access, which is really bad. So that's why you want to disable root access when you configure SSH. I can show you quickly how to do it. It's not in one of the topics today, but I just realized maybe we should talk about it since we are already kind of mentioning that. You go to /etc and then SSH and then SSHD_config. That's a configuration file. It is in text. And then you look up root, permit root login. The default is yes. You want to turn it into a no. Okay? Now, after you turn it into a no, you save the file. I use VI. And then you exit from the editor. Is your system safer now?
No.
No. because all you have done is to change a text file. Once SSH is running, which it is, it doesn't reread the text file again until you ask it to. So what you need to do is to restart the SSH service. Remember this path?
Stop.
Sorry?
Do stop on this stuff, right? After this path, do stop.
You can just say restart.
Only restart that.
Yeah, restart will automatically stop it first and then start it up again. Yeah. For certain surfaces, you can just say reload, which saves you time because it's not actually stopping the entire thing. It's just asking the surface to reread the configuration file. Like Apache can do that. If you just mention this, SSH, if you just run it without the word start, stop, and whatnot, it tells you the option. So this one does have the option of reload, which is slightly more efficient. It doesn't actually stop and then start it again. It's just reloading the configuration. But I usually just go for restart. So I can say restart, and it shows you that it's restarting the OpenBSD secure shell server. And the next time I do the PS command, you can expect a different process ID because I did stop the original process and then start it all over again. But this time, at this point, someone cannot log into this system as root remotely anymore, not directly. Are there any questions so far? Because I have just demonstrated not only how to identify a surface, but I also tell you how to assess how dangerous that particular surface is, and in this case with SSH, how to make it more secure. At least turn off, permit root access so that people cannot, try to hack in as the root user. Are there any questions at this point? No questions? Okay, if there are no questions, we'll continue to read the notes here, which is basically reporting, it's just repeating what I just said about the IP address of 0000, and also the local host is 127.0.0.1. I just realized that I forgot about one really important command that has a lot to do with networking. It's ifconfig. If you just type ifconfig and then press the enter key, it shows you all the network interface cards, okay, virtual or not, that are active at this point, that the system is recognized. So if you just type ifconfig as root, okay, you cannot type this command as the end user. You have to type it as root. It shows you, a lot of information.
It's like the IP config for
yes, it is like IP config in Windows, except the syntax is a little bit different. If you want to do any configuration, this one has a different syntax. It shows you that ETH0 is the name of a network interface. The type of the interface is an Ethernet, and this is its hardware address or the MAC address. It has an IP4 address of 165.196.144. You guys can try to log in as user on this computer right now with the password of user. It will work. Well, it should work unless they set up the firewall to block it. I don't think it's blocked. We have a broadcast address of 165.196.100.127, and this is the network mask, which is 255.255. Because the network only has 128, can only have that many hosts. Only that part is reserved for the host address and not the network address. And then we have LO, which is our loopback address or the loopback interface. And this one has an IP address of 127.0.0.1.
And that's going to be across the board the same. That's going to be the same. The INET address is the same for everyone.
Yes, that should be the same because it's local to your computer.
On the LO, on the loopback.
Yep, on the loopback. Okay, here comes another question. It has to do with connecting all the dots that we have mentioned earlier. How do I test SSH right now? Okay. To make sure that I cannot log in as the root user anymore. I don't want you guys to help, okay? I don't want to say, okay, you guys try to log in as root to this IP address. How can I do something on this particular computer right now to see if I can still log in as root.
Type in SU and see if you can log in as root.
Well, SU does not go through SSH.
SSH, you're at
B27.
Yep, SSH, and then say root at, well, I'm already that user, but if I'm not, I can always say root at a particular address. I can use either one. I can actually say SSH root at 165.196.144, because remember, which IP addresses is SSHD listening to? Everything. So I can use my actual Ethernet address, or I can use the loopback address. Both should behave the same way. Well, let's go ahead and give it a try. So I try to log in as root, and I specify the password. Permission denied. Very good.
Try as a user.
Sorry?
We try as a user.
Okay, we can try out as user.
But if the password is incorrect, it'll tell you password is incorrect instead of permission denied.
I do not know. Okay, let me check.
pretty ambiguous.
You want it to be ambiguous. Yeah, it's the same thing. I just
Okay.
type in the wrong password.
So it won't even tell you if you got the password.
But that makes sense.
Yeah.
Because you don't want to tell a hacker and say, oh, congratulations, you got the username right. Now, let's see if you can get the password right. Right? That's like open invitation. It's like, okay, you get the first half done. Let's see if you can get the second half done too. So you want to give them as ambiguous as a message and say, I don't know, it just doesn't match. But what doesn't match? Is it the username or the password? Not going to tell you.
Now, can you configure so that the root is not actually the root, that the root is actually just another user, and then configure the root to be named like something different? You know,
I
Cookie
suppose
Monster?
you can, but if you do that, you might break a lot of commands that makes that assumption that the root user
At
is
least for the
has
next
the name of
IT guy
root.
to walk in there and do something.
Yeah, there will be a lot of cussing. Yeah, there will be a lot of cussing. If you guys want to do it and just play around and see if that works, do it on your own with a virtual machine. The place to do it is, if I remember correctly, it is there's a file called passwd, and you can see that it has an entry for root, and this is the user ID of root, which is supposed to be 0. Now, I don't know what's going to happen when you change the username to something else. Okay? If you change the name to something else, most commands will still work because they work only with the number 0.
Right.
User ID is 0. But there might be programs out there that depend also on the
labels.
username of root. So those programs will be host if you change it like this. And besides, you're not supposed to change passwd, the file itself either,
Why not?
because you can lead to inconsistency, and inconsistency between password and shadow can render certain things completely broken and unusable. So if you want to mess around with this stuff, go ahead. I'm not going to do it. Any questions at this point? No questions? Yep, go ahead.
Isn't it true that Ubuntu doesn't prevent you from using root, but kind of
It has.
masks
It uses sudo. It uses the concept of sudo, and I don't understand why Debian is different from Ubuntu in that respect. Debian always has a root user. You can't change the system. Later on in the semester, we'll actually do it. Okay, we can say, okay, what if I don't want to allow anyone from using the root account itself, and instead use the command called sudo, sudo, to execute commands with root privilege. In the end, they are equivalent. When you use sudo, sudo, you can say sudo-s, and it will open up a shell using the root user privilege. In other words, you did log in as root in the end. And with this, you can disable the root account by enabling sudo also. You can also pull the rug under yourself. In other words, you can disable the root account and mess up the setting up of sudo at the same time, and render the system not really usable at that point because there's no way to switch privilege to a higher level. then you will have to boot with a live CD or something else to fix it up. But it's fixable. That's a good question. All right, so we are done with that particular slide, and we are moving on to disabling the ping response. Now this one sounds to be a pretty simple thing. We talked about it last time. What we call ping is a basic mechanism to see if another computer, I should say network interface, is reachable at a particular IP address or not. A client computer, in this case, is a computer that is trying to confirm the existence of a host at a particular address. Well, let's go ahead and do something here. The one thing I can ping first is myself. All right, I'm pinging myself because 127.0.0.1 is my loopback network interface address, and I'm just pinging myself here without even using the NIC, my external NIC. It's working fine, and I can also ping myself using the IP address that I have identified earlier that I have forgotten. So we can say ping 165.196.144, and it should respond because that's the default behavior of any system. In Debian, and I think in Ubuntu, by default they respond to pings as well. Okay. Are there any questions about this particular mechanism? Yep. Go ahead.
What did you do to stop me?
Control C. And it even tells you, how many or what is the percentage of loss, and the average response time, and so on and so forth.
I'm not seeing the percentage of loss on it.
You're not?
I see the TTL 63, ICMP required.
It could be run it as root.
Time?
Run as root.
I am running as root.
Hmm.
Yeah.
That's weird.
I'm also on Ubuntu, not Debian.
Oh, okay.
I don't know if
Minor
that makes a
differences.
difference.
Yep. There can be minor differences. Okay. Now, ping doesn't use TCP/IP. It uses IP but not TCP. So what does that mean? It uses the IP address the same way, but it's not a TCP protocol. It is an ICMP.
Right.
I was about to say ICMP protocol, which would be redundant.
An ICM protocol.
ICM protocol, that's it. Yep. What it is very simple. When your computer receives a ICMP echo request packet, it will respond with a ICMP echo response packet. That's all. Okay? You give it a little request, it sends back a reply, that's it. No information really passed along the way. But you know what? The other side knows that you're there. Okay? Is that a big deal? Well, it's a big deal and it's not a big deal, because if a hacker really wants to get into your system and launch an attack, just turning off ping is not going to stop them. Not at all. Okay? It just takes them longer to find you. Okay? So if you turn off ping, you make your system slightly more secure, but do not get the illusion that if I stop ping, my system is a whole lot more secure, because it's not. Okay?
How do you? Oh, okay. The echo 1.
Yep.
Greater than. Okay.
So the command to do it is this command here. Okay, these are the ping commands. If you want the system to stop responding to ping, you can do it here. And the command to do it is this command here. And I want to explain this command. So let me copy and paste it onto the command line.
Would you have to do the same for IPv6, since IPv6 is coming out as well? He's doing it for IPv4.
Well, let's see if it has a similar thing. Yeah, I think v6 probably has a similar thing. ICMP. Nope, it only has a rate limit. It doesn't have a response flag for ping. If you just do a IPv6, do a search of stop ping Linux IPv6, you'll probably get to the response line. The first link is the right one. Okay. But I do want to explain this command here. Now, this command doesn't look very difficult, but it is conceptually. This can be very difficult. Okay? Let's see what it's doing. Before we do that, let me run the command and then see if I have stopped pings. Okay, so I would ping myself 127.0.1, and there's nothing. It worked. Okay. Now, I can teach this class in one of two ways. I can teach this class and just say, okay, type this command, press the enter key, and it works, and then walk away and move on to something else. Or I can teach this class and say, look at this command here. It looks really simple, but it's not. And I'll explain how it does its work. That's the way I want to teach the class, because this is a Linux class and you really need to know this kind of stuff to become a good Linux administrator. Okay, so I'm going to do a Control-C, and this time, guess what? I have 100% packet lost. Was that expected?
Yes. I've got the same thing.
Exactly. So that's good. It means it's working. But now I want to focus on this command, which doesn't seem to be very difficult, but it really illustrates a lot of concepts in Linux and Unix type of operating systems. The first one, echo 1. That's the command. That's the only part of the command that does anything. What does it do? Print 1. That's about it. In other words, on the command line, if you just say echo 1, it prints 1, and that's all that it does. So why would that be able to do something that can change the behavior of the kernel? The magic is not the command echo itself. The magic has to do with this part, the file, the path of that file. The greater than symbol here is not saying that 1 is greater than gibberish, okay? It's actually what we call a redirect operator or redirect symbol. So right here we have a concept to explain. How many people are familiar with the concept of redirecting already?
Right. Well,
Okay, we have some, okay?
so you're redirecting, basically, instead of redirecting it to print on the screen, it's redirecting it to go to this.
File,
Right.
quote unquote file. Yep. Okay. So redirection is basically saying, instead of printing something, because every single program in Linux has a few files already opened and available to the program. One is called standard in or standard input, which normally correspond to the keyboard. Okay, whatever you type is called a standard input to a program. One is called standard output. Standard output is typically corresponds to the output on a command line interface. These are the two that I want to explain. There's standard and then there's one more standard. I cannot remember the last one. But there are 4 of them. Okay. When you say echo 1, and let me just redirect to a normal file, which is in the temp folder, I'll just call this test. Okay. You can see that this command is no longer printing 1 on the screen. Well, the reason is the redirection is telling the Linux operating system to say whatever this command is outputting, capture that output into that file. So if I type or cat that file to look at its content, I should know what it has, which is just 1 itself.
Okay. Because you just created that.
I just created the file. Redirection will automatically create if the file does not exist. In fact, it will always overwrite. If the file is already there, it will overwrite its content automatically.
Sounds like it could be a nightmare for somebody.
It can be bad if you do something like this, because now the file only has 2. The 1 is gone.
Right.
If you don't want to overwrite and you want to append to the end of the file, you use greater than, greater than. 2 greater thans means append. If the file does not exist, it will create it on the fly. If it does exist, it will only append the content that you specify to the end of the file.
Right, just add it.
Yep, it's just adding it to the end. Okay. So redirection by itself is no magic, right? I mean, it's just capturing the file, the output of a program as a file instead of displaying that on screen. So the magic has got to be this really kind of special path. This is not a regular file. What comes to your mind when we talk about a regular file, especially on a regular system and not on a live system? Go ahead.
Like the static file, so it doesn't change.
If you turn off the computer, the file should still be there. When you turn it back on, the file should still be there, right? Okay. But this is not one of those files. It only looks like a file in the sense that it can be accessed using commands that you can use to access files. In other words, you can cat it, you can redirect output to it, you can redirect input from it. It behaves just like a file. But it is not an actual file in the sense that there's nowhere on my flash drive or my hard drive or even my RAM drive that has a representation of this thing. This actually directly maps to a parameter inside the Linux kernel. Okay? In other words, by writing a 1 to that file, I am communicating directly with the Linux kernel and say, okay, stop responding to pings altogether. Yep.
Does that mean as soon as you shut off the computer and you turn it back on again, your change is gone? It goes back to.
That is correct. Yeah, if you follow the link in that in the thing that I just wrote, there's a link to an article that talks about this command. There's a way to make it stick. You have to create a file, at etc/ciss342 sysctl.conf, and then you specify a line which is icmp_echo_ignore_all equals 1, and that will make it stick because that is a regular file. The .conf file is a regular file that your kernel will look at when it starts up. So you can make it stick if you want to, but this doesn't make it stick.
This is only good for this session only.
It's only good for this session. As soon as you power off or reset the computer, that setting is gone. Okay. What else do you think you can control using this kind of strange way of talking to the kernel? A lot of things. Okay. Last time I taught assembly language programming. One of my students came with a laptop computer with a NVIDIA graphics card, and you can kind of already guess what kind of trouble he got into. But one of the problems that he got into was for some reason the NVIDIA driver for Linux did not turn off power management automatically. So his laptop was running really hot, as in you cannot put your palm too long on the notebook computer, kind of hot. Yeah. So we were scrambling to try to find out, how do we re-enable power management? Because power management means if you're not playing games, that is graphics intensive, don't try to clock up all the graphics processor and consume that much power. And we found a simple solution. It's just like a file like this one, /proc/ blah 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 blah, and you just have to write a 1 to it. And the file name implies power management or something along that line. So once again, it is not a regular file. It maps to, in that case, it maps to a configuration variable of the NVIDIA graphics card driver. So what is the advantage of this particular approach? Exposing certain internal parameters of the kernel and drivers as quote-unquote files. What would be one of the advantages of this approach? I wrote it in my text, but I want you guys to think about it right now. Yep.
Make an active change on the fly, and you're done. Just one line, you're done.
And did I use any special command?
No.
Can you expect echo to be on a Linux system?
Absolutely.
Do you expect redirection to be capable in any type of Linux CLI?
Absolutely.
Yeah. So that means you can write a script to do this kind of thing without any special commands, which is really handy. Yep.
You can also assign it then privileges, read, write, edit.
Mm-hmm. You can also do a tar. Okay, what is tar in the setting of Linux? I just need a quick explanation of tar.
Stinky bits.
Tar is tape archive. Okay, it's a way to create a single file out of a folder or multiple files. In other words, if you want to capture all the parameters related to networking right now, all you have to do is to do a tar with /proc/sys/net, and a tar file that you create, which is from reading all those files. Those are all configurations of networking. You just created a snapshot of the settings right now. Okay? In other words, you can now leverage all the utilities that you have for dealing with files. Now they will also work for configuring parameters in the kernel.
I like that.
Grep will work, find will work. A lot of the files utilities will work because these are just like files. They're behaving just like files. Okay, I can give you another scenario. Okay, I go to /proc/net on Monday, and since I did not drink enough caffeine on that day, I forgot, what was the file name that turned off all the pings? I cannot remember the file name. I could go into the subdirectories, do a whole lot of ls, or use tree, to try to find the file name. But I remember there's a command called find, and I'm going to find in the current directory, and the name of the file that I'm trying to find has ICMP in it. Oh, okay. I think I need a dot here. Oops. And a dot here. Yep.
I think it's the quotes.
Sorry?
The quotes?
The quotes?
Yeah, the double quotes are on
No, I think it
Is
needs
supposed
the
to be single
quotes.
quotes?
Sorry?
Should it be single quotes or is it single or double quotes?
Single quote and double quote should behave the same way here. It's only finding that one. It is as if the asterisk, the wildcard, is not working.
Should it be asterisk dot ICMP dot asterisk? I mean, it's kind of like the star dot star wildcard search.
Well, in a case like this, what do?
Oh.
You ask the man. You ask the man. Okay, so I'm looking for regular expression, for example, dash name, dash. Okay, I'll just use regular expression. Then I can use wildcards all I want. In this case, the dot is important. Nope, it's still only finding that one. Ah, that's
You're in the wrong
interesting.
directory.
Yeah, I'm guessing that.
Ah,
There we go.
That's it.
Got the wrong directory.
Should be
Always know where you are.
It should be proxys, right?
yeah.
Find in sys anything that starts with ICMP. Still not finding it.
The dash name works. The original command.
And I don't need a dot. There we go.
Okay.
Yep.
Okay. So
Okay.
now.
But
find
what I'm
source.
trying to illustrate is not that sometimes I forget how to use find, but the fact that any utility programs that can help you find a file or look into the content of a file, like grep, it will work with these files too. Even though they're special files, they still behave just like regular files to these utility programs. So that's why, in Unix or the Unix type of operating systems, such as Linux, everything is treated like a file. What about your entire hard drive? It's a file. Remember last time I showed you the dd command that can wipe your entire hard drive with one single command? That's because your entire hard drive is considered a single file. It's a special file, but it is nonetheless considered a single file. What about your DVD-ROM? The content of your DVD drive? It behaves exactly the same way.
It's
Now, if you want to copy like DVD protected or encrypted DVD content, you do need a special library before it can decrypt the content. But nonetheless, after that, it is just considered a single file. So you can capture the entire ISO with one single command. If someone gives me, a particular ISO or a CD, I'm looking for the CD right now. Okay, I have a CD here. And let's just say that I'm the legal owner of this CD, and I just want to make a copy as a backup. Well, first of all, is it legal to do that?
Yes, absolutely.
Absolutely legal, right? How can I do something like that? In Windows, how do you make a backup of a CD? You get Infra Recorder or some other programs to help you capture the ISO. In Linux, I do it with this command. dd if equals slash device slash cd-rom, or it's, whatever drive name it chooses to use. Of equals whatever.iso, and if you want to speed up the process, you specify a reasonable block size, and that's it. That will rip the CD. It will capture the ISO image of a CD or a DVD if you have the decryption library already installed. But this is only made possible because the entire CD, the content of the entire CD, can be considered as a single file. Okay. Do you think this concept is also in Windows?
Yes.
Yes. The answer is yes, except Microsoft does not really promote that kind of utility. So even though you can do it that way, most of the commands or most of the user commands do not do it this way. It can be quite dangerous if you think about it.
90% of Windows users don't even know how to get to the
And they're better off not knowing.
Exactly.
No, I'm not kidding, because remember, when you have a Windows Home, the regular user, the default user, is running as administrator. And as administrator, if you look at the entire hard drive as a file and you write something over that, you have just destroyed the entire hard drive, or at least the important part of it. What is the first part of an entire hard drive? The master boot record. And what does it contain? The partition table. Yep. So overwriting that one sector, 512 bytes, can be disastrous. Very bad, very bad. What if you do that to a Linux system? Just put it with a live CD and rescue it. All right. So are we okay with this concept? Why this command works and what is the magic of this command? The magic has nothing to do with echo 1 nor the redirect. It has to do with this path here. Now, for those of you who want to look into this particular directory, there's a lot of junk. And this actually has a lot to do with client-side security. Why? What are all those numbers? Each number corresponds to a process ID. So when you look at this screen here, I'll just pick one number. 3891 is a process ID. That process is active and running while I type the ls command. Whether it's still active or not, it depends. Okay? So let's go ahead and look into one of these directories and see what's in one of these directories. So I'll go into, let's say, 3891. And then do ls. Whoa, it shows me a lot of stuff. What do you think these are telling me? Let's pick something that's easy. CWD. It's telling me the current working directory when this process started. Okay, let's do a cat and see if that's the case. Cat means concatenation, but it's for the most part you can also use it as type in DOS. It can show the content of a file. Oh, okay, CWD is a directory, so we'll take a look at CWD, current working directory. I was mistaken. It's not it's a symlink to something else. There we go. It's a symlink to root, which means when this process was started, the current working directory was the root of the entire file system. That's what it's saying. What else do you think is going to be important? What about CMD line? What do you think that's going to tell me? That's the command line that whatever was starting this process used this command line to start up this program. Let's check out what it is. Remember, I just picked something randomly. Okay, so this was the command line. It's really long, but this was the command line that was used in order to start up this process. Now this right here can be a problem. Mostly on a server system, but on a client system, you also have to kind of watch out for this kind of thing. How many people have some experience with databases? Okay. when you want to start up a database client like MySQL or PSQL, you can supply the password on the command line itself, can't you?
Yes.
That's what it will show here.
Uh,
It will show here, it will also show when you use PS, because you can make PS display the command line too. And any user can do it. You cannot lock that out.
Why not?
Well, that's the way the system behaves. So that means if you want to start up a MySQL client, now we are talking about a client system here, right? I mean, can we expect to run MySQL client on a client system?
Not usually.
Absolutely, right? So if you use MySQL-P and then type your actual password after that, and you have a long session of running MySQL, if someone else logs into your system and type PS, I cannot remember the full extensions, they can display the command line that you used to start up MySQL, and if you type your password as a part of the command line, it will show, and that person will be able to.
But that's only if you type the password as part of the command line.
That is correct.
Okay, so if you do not type the password as part of the command line,
Then
it should not
you'll be okay.
Okay.
Yep. Mm-hmm.
Good to know. But most people who are clients aren't going to know Linux that well to see this in it.
I would not make that kind of assumption.
Most.
I still remember, back, this is a few years ago, how many people have used a power server or know what a power server is? Kind of, okay. It's a computer server for students to do the web-related projects for the most part.
GDP is good.
And the system was being backed up, to another system. There's nothing really top secret on Power itself. Mostly it's just homework assignment of students. No social security, no employee ID, address, names, and so on and so forth. So it's no big deal. If it does get cracked, it's no big deal. This is before I started to manage the Power server. Whoever did the management of Power server decided to mount a remote file system onto Power and then do a tar command to back up the files onto the remote file system and do it that way. Okay? That by itself is okay. I mean, it's there's nothing really bad about it. It's just a little bit dangerous if they don't test everything ahead of time. But the way they mount the remote file system is just like what I said. They specify the password as a part of the mount command. But mount is not as bad as MySQL. Why is it not nearly as bad? How long does it take for mount to finish its job to mount a remote file system as a local point in your current
Less than a
file
second.
system?
Like,
Typically a fraction of a second. So the chances of someone running PS right at that moment to capture that command line is pretty slim. But it is still a security risk, because now if someone did capture that, we'll now have the ability to log in to the other system, because it would have captured the username and password of the other file system.
but only if the password if the password's actually been changed and you have the password stored in that tar file, in that tar.
We're not talking about tar. We're talking about the command line of a
Right.
process.
Okay.
In other words, if I think that something like that is going on as a hacker, I'll just go ahead and run a cron job of some kind and run PS, just repeatedly. Every second or so, because PS doesn't take too long to execute. So over time, I might eventually capture that one single command line that I'm looking for. Now, if I know approximately what time the system mounts the remote file system, I can even go to the extent of running a compute-intensive program at the same time to slow down the system. So the mount command would take longer to run, and then I'll have a better chance of capturing that command line.
Wouldn't the actual user, wouldn't they actually see that, hey, there's something going on? Obviously, all of a sudden we're going from like 50 miles an hour down to like 3?
Well, that depends. It depends on the system administrator whether there are tools set up to monitor unreasonable system load and stuff like that.
I'd imagine at this school, there's, under your direction.
Remember,
Yeah.
but I don't have to run the script on the system itself to generate the load. I can just use a remote system to keep requesting stuff from the web server part of Power. I can generate load in many different ways.
Right.
That's why they don't trust me with the keys to these rooms.
You know, the whole time you're telling me that story, I was thinking about the computer under your desk at home.
All right, so let's go back to this part here. So are there any questions here? No? Okay, I'm only exposing a little bit of what the Linux file system is about, especially with /proc. There's a lot of stuff going on in /proc. So going back. And this is the last note that I have typed. It has to do with Bastille.
Oh, that's the.
Bastille to the rescue. All right, so let me go back to the previous one. Let's see, did I talk about this one? Nope, I haven't talked about this one. This is a really short slide, but nonetheless, we need to talk about it. Because according to the topic list, we are supposed to talk about what surfaces we should turn off and how to turn off those surfaces. Okay? Now this class has no prerequisite of any networking experience or any Linux experience. What if you turn off something that you're not supposed to?
Oops.
Well,
Restart.
the first question is, does it always make the system more secure?
No.
What if you turn off Clam AV?
Less secure.
It doesn't make the system any more secure. What if you turn off a intrusion detection surface? It makes your system less secure, right? So we cannot just say, well, if you cannot tell what that surface is doing or it's not something that turn it off. I cannot use that approach. So what you need to do is to basically at least just pay attention to the ones that are listening to an external IP address. In other words, when you run netstat-tlnp, only the ones that are listening to non-local host are potentially open for an attack from the outside. Okay?
Shouldn't U be added to that for UDP traffic?
Yeah, you can also add the U for UDP. Yep. So it would be TUNLP, for that. So the netstat command earlier can do that, and let me go back and change it and add the U for UDP, because I want to make sure that I do not leave that out. Yeah, Bastille is nice, but only once you understand what it's saying. So let me go back to, what was that one? Netstat is going to, who is listening to which port?
It doesn't support Ubuntu though.
Sorry?
It doesn't seem to support Ubuntu.
What does not?
Bastille.
It doesn't have a package for it?
No, it's got Debian, Gentoo, SUIC, Mandrake, Fedora, Enterprise. Also supports Mac OS X.
Well, Ubuntu is supposed to be Debian type,
Right.
so it should work in the Ubuntu as well.
Only one way to try it out.
Just try to install it in Ubuntu. I think you can find it. Okay. With a typical Debian Ubuntu setup, the two exposed ports, one would be for SMB, which is a Windows share surface, and the other one is called port map, which is NFS or network file system related. So those two can potentially be problems because they are corresponding to file systems, and they also listen to external ports or external IP addresses. Okay. But how do you turn it off? Well, it depends on what we are talking about, because every surface can potentially have a different way or a different type of configuration file. So there's no universal way that works for everything. And you also have to know what you're turning off too. So the best way is not really to mess with that stuff, yourself, unless you have to turn it, do it yourself. The best way is to use what we call, the program is called Bastille. And Bastille to the rescue. And you can also follow this link to its own website. I'm going to open that up. This is a what we call a hardening tool. When we harden an operating system, we are improving its security settings, so it's harder to hack into the system. And it's not only limited to network surfaces, it also applies to other things that can make the system more susceptible to security risks. But at this point, okay, the installation of Bastille is easy. You just run aptitude install Bastille, or if you like apt-get better, it's apt-get install Bastille. That's all. The question is, when you run Bastille, do you know what you're doing? Do you know what you're turning off? Do you know what kind of file permission you're disabling? What is the impact of disabling those permissions or turning off those permissions? Those are the questions. Because if you don't know what you're turning off, it can be bad, okay? Because you can make certain things, impossible to do later on. So let me see if I can do it here.
On Ubuntu, it doesn't seem to be working. I keep getting an unable to locate package Bastille. I do an apt-get, and then it's also saying that I need to
switch to Debian. Switch to the dark side of the source. Yes?
Does it work similar to Microsoft baseline security?
I do not know because I don't use Microsoft products.
Okay.
Sorry. But I can run Bastille right now, and you can see what it looks like. Bastille-C. If you do not specify the -C, it will try to bring up a GUI interface, which is only using TickleTK. The live DVD has that package already installed, so I could have run it in the GUI mode. But since some of you may be running this inside a virtual machine that has no GUI, you want to specify -c for the command line version of it. The first part is a whole bunch of disclaimer, because especially with this kind of a tool, some people can come back and say, well, I ran Bastille and my system still got hacked. I want to sue you. Okay, so the disclaimer is really just for that purpose. And you have to type accept, like ACCEPT, to turn it on. Please answer all the questions to build a more secure system. You can use the tab key to switch among major screen functions, like each question's explanation area, input area, and button area. So if you press the tab key, it just switches between the main areas. So I just go next. Okay, would you like to set more restrictive permissions on the administrative utilities? Okay, the default is no. It comes with an explanation. In general, the default file permission set by most vendors, and Debian is one of the more secure ones too, are fairly secure. To make them more secure though, you can remove non-root user access to some administrator functions. If you choose this function, you'll be changing the permissions on some common system administration utilities so they are not readable or executable by users other than root. These utilities, which include linuxconf, fsck, ifconfig, runlevel, and portmap, are ones that most users should never have a need to access. The keyword here is most. Okay? This option will increase your system security, but there's a chance it will inconvenience your users. Would you like to set more restrictive permissions on the administrative utilities? Well, first of all, do we know what we are doing? How does file permission work in Linux? We haven't talked about it yet. Okay? So, best to leave it and say, okay, let's not touch it for now. Now, this is just a live system, so it really doesn't do anything to the system. Next one is the following questions all pertain to disabling SUID root permission for particular programs. What is SUID?
super user.
Set user ID But what does that do to programs? SUID is a particular flag to apply to programs or executables. It can be scripts, can be actual programs in Linux. Yep.
It runs the program with root privileges.
Yep. It doesn't matter who runs the program. When the program does run, it will run with root privileges. That's what it does. This permission allows non-root users to run these programs, increasing convenience but decreasing security. So in theory, it is a bad idea to use SUID root. If a security weakness or vulnerability is found in these programs, it can be exploited to gain root level access to your computer through any user account. So it can be very bad because someone can hack into a regular user account, find a program that has a security flaw to begin with, that has the SUID root flag already set, and then that program can potentially, or the hacker can potentially gain root level access. If you answered yes and then realize later that you do need SUID permissions on a specific program, you can always turn it back on with the command chmod chmod is change mode, u plus s user plus SUID and then the file name. How many people will take a screenshot and make sure you remember these instructions before you click, yeah, go ahead and do it? Well, if you don't, what if later on you need to switch, or what if later on you have a problem and it doesn't even tell you that it is related to SUID root? So you have to remember all these things because we are making changes to default settings of a particular operating system. Debian is not just a version of Linux, it is an entire distribution. In other words, when Debian has a package released, it makes certain assumptions of how the system is going to be configured. If you change the assumption, if you change the system so it's no longer consistent with the assumption, it is possible that some of these things that is really a good thing to begin with, it will improve the security of your system, can break certain assumptions of other packages from Debian. So you have to keep that in mind. It can happen. If you decide to do it, make sure you take a screenshot of this, write a note somewhere so that you can remember, oh yeah, I ran Bastille and it warned me about this. Okay, so that later on, if you encounter problems, you know where to look for problems and how to fix those problems. Would you like to disable that? Okay, we'll click yes. Would you like to disable SUID status for ping? In other words, if you do it this way, then ping is no longer runnable by a regular user. Well, let's say yes, and then see later on, we'll check and see whether it's actually disabled or not. Should Bastille disable clear text R protocol that use IP-based authentication? R tools, which include rsync, rshell, rsh, and so on, they are remote utility programs. RCP stands for remote copy. You can copy files remotely across two systems connected by a network. Unfortunately, the R protocols are clear text protocols. In other words, it authenticates to the other system, transmitting your username and your password using clear text. Is that a problem? But my network is secure. I can trust everybody in my company. Well, you can't really trust anyone, okay? Because someone can walk into an establishment and plug in something to a wall jack, okay? And depending on how your network is set up, if it's a switched network, it's a little bit safer. But if you run a network hub, then it is problematic, okay? Because when you run a hub, what happens? What is the main difference between a switch and a hub?
Hub broadcasts out of all ports.
Yep. So when you transmit your username and your password as a part of a protocol, you're really intending to talk to one computer. What happens to all the other computers on the same
They
subnet?
receive it.
They all get it. Yep. But most programs won't pay attention to that traffic, right? Unless you're running a sniffer. Okay, we'll just say yes here. Do you would like to enforce password aging? Now this can be very annoying to some people. What is password aging? Just like cheese and wine.
That's cool. Does it make you like
Expiration date, and
Yep.
password.
Okay, your operating system's default behavior, which we could change here, is to disable an account when the password hasn't changed in basically 100,000 days. This interval is way too long to be useful. We can set the default to 60 days. At some point before the 60 days have passed, the system will ask the user to change his or her password. At the end of the 60 days, if the password has not been changed, the account will be temporarily disabled. We'll make sure this warning period is at least 5 days long. We would make this change in /etc/login.defaults. Okay? If you're running a client system and you're the only user, you can probably make this change and you will remember it. Well, the first time your account gets disabled, that will make sure that you remember it for the next 60 days. But if you're administering a system where you have other regular users, you really need to make sure they understand what is going on. Because otherwise it can lead to a lot of frustration. Does it really help in terms of the security of your system?
would it help against like people who are trying to guess your password? That's about it, right?
Mm-hmm.
But they're basically just like basic hacking.
Well,
Okay.
unused accounts.
If you're so go ahead.
Well, it prevent unused accounts or accounts that or people went away from the company and
Yep.
they would finally age out on their own.
Yep. It also disables accounts that are set up by viruses and malware. Because if they don't reactivate the account, it will be locked up.
But a good IT person would make sure that those accounts are disabled anyway, right?
Yep, you would hope so. But this is a client system, and supposedly we should not have to worry about that sort of thing. But it can happen to a client system too. Okay, so we'll say yes. What about the default UMask? What is a UMask? In other words, as we run Bastille, we are running across concepts and ideas that I'm supposed to talk about in the next few weeks. So this is not a very good time to finish Bastille, but I do want to show you the tools so that later on, as we continue to talk about these concepts, we will continue to know, okay, what are we talking about? Well, it is in Bastille, it asks me about this question, and the implication of this is blah, 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 blah. UMask, okay, it doesn't have a little explanation here. The UMask sets the default permission for files that you create. Bastille can set one of the several UMask in the default login configurations. In other words, well, the first thing we have to do is to talk about the permissions of a file. Then you have a user owner of a file, you have a group owner of a file, and then you have others, everybody else. Okay? Because before we talk about that, it's not very meaningful to talk about the UMask. Okay? So that means at this point here, I probably should not be running Bastille anymore because we are getting to a point where we don't really understand what a UMask is and its implications. Are there any questions at this point about Bastille? Yep.
Does it keep a log of all its changes so you can go back and reference that?
It has an ability to undo the changes. So I would assume that it keeps a log or some sort of undo, differences, like how you make these changes. Yep. Yep, absolutely. That's a very good question. So what I'll do is I'm going to quit here. And I guess Control-C always quits. And I'll do a man Bastille. And you can see from here, one of the options here. One option is to run it in batch mode. So it will take all the default answers, finish configuring the system, and say, have a nice day. Okay? Would that be a good idea in this class? Probably not. Okay? This one is a -C. It is available to Linux only. It's not a Linux only mode. It is just available to Linux only. It brings up the text interface instead of the GUI interface. Okay? And that's what I did. -L list applied configuration files. In other words, it tells you what files have been changed by running Bastille. So that means it keeps a log of the changes that it makes to the system, which is a very good idea. And this answers your question. -R. -R revert Bastille modified system files to the state they were in before Bastille was run. But there's a note. If any changes to the system configurations were made in the interim, those changes should be reviewed again to make sure, 1, they still work, and 2, have not broken the system or compromised its security. But there is a feature to revert the changes, the modifications. Are there any questions about Bastille? We'll come back to Bastille from time to time, because it's a very good tool. But you do need to understand, all the concepts first. What Bastille does is it makes sure that you don't have to remember the syntax of dealing with all the configuration files. It also removes the danger of messing up the configuration files. In other words, what if you have a spelling mistake in one of the configuration files? Well, that can be problematic. The service can refuse to start up again because there's a syntax problem in the configuration file. Bastille helps to remove that kind of problem. It also helps to remove the problem of, okay, where is the path of the configuration of the login to enforce 60 days aging of the password? I cannot remember. But Bastille will just, you don't have to remember anything, just the concepts. So it's helpful in that respect, but it is not very helpful until we understand the concepts of making your system more secure. Are there any questions about Bastille? No questions? Okay. Are there any questions of how to get to the man page? Are there any questions about how to use man itself?
Type man.
Man, yes.
Type man.
No, man.
Man.
It's man. It tells you how to use man.
What does man cave do? Man cave do anything?
Man cave? No. It will say unknown. I think just do it. Man cave. No manual entry.
For cave?
In that case, there's no entry.
Maybe it's automatic.
You can always write your own man page for cave. All right. So this is all that I have typed, because I have been spending a lot of time on the live DVD. I will fix it to the point where, this is my hope, I haven't done it yet, but I think I can make it so that it can automatically detect that you have an NVIDIA chipset or you have an NVIDIA card, automatically load the kernel driver, which is NVIDIA, the kernel module is called NVIDIA, and then automatically run NVIDIA-X settings to set up the xor.conf file before the rest of the bootstrap process. So that should bring it up, bring up the GUI interface when you have an NVIDIA graphics card or chipset in your system. Okay. But I don't know how long that will take because baking those ISOs take a long time. But that's what I'm going to do.
You want to borrow my laptop for the night?
I have one computer at home that has an NVIDIA chipset. So I'm good there.
You play Eve Online.
Say Eve?
Yeah.
My NVIDIA video card has no fan. It has no. It's a passive cooling kind of video card.
Oh, okay.
Because I don't play games on my system.
You do, but they're on other people's computers.
And that's for other purposes that I cannot talk about in the class. Just kidding. All right. Well, topic 4 talks about how to configure client-side operating system services and optimize them to allow performance of necessary jobs versus security consideration. Doesn't that sound kind of familiar already? A lot of these are big. There's a lot of overlap. Whoever wrote the curriculum did not really think about it. It's copied and pasted. Has anyone read the curriculum of ciss341, the Windows version of this class?
Oh, I'm in. Is that the one with Windows 7?
Yeah.
Oh, okay, yeah.
Do you recognize some of these terms? It's a straight copy and paste. What will get interesting is when we get to configure network surfaces. Web browsing doesn't really have a lot to do because it's mostly client side. It's not a server side kind of thing. Email access is the same thing. How many people still use a dedicated email client? Do you know what is an email client? How do you check your email? Let me just rephrase the question.
Thunderbird or
Hmm?
Thunderbird?
You use Thunderbird, so you do use a client then.
Oh.
How many people still use a particular program to check email instead of using Gmail or Yahoo or Hotmail? So what do you use?
Outlook.
Outlook? Okay.
There's a lot of people
Can't
that-
help you there.
Like, there's a lot of people, actually, most of the companies I go through prefer to use Outlook, but I'm pulling them off of Outlook, actually. Because it just,
So you want them to use OWA instead, Outlook Web Access?
no, well, the main problem I'm finding is that the synchronization of the sent folder
Mhm.
with Apple Talk and Apple products in general tend to work right. So I threw them, the last company I did this for, I just threw them onto the Gmail stuff and said, here, it's cheaper there anyway than it is through, because they were going through GoDaddy.
Mhm.
And there was something with, I don't know if it was Outlook, or if it was Outlook with Apple, or if it was GoDaddy with Outlook with Apple, or GoDaddy with Apple, but somewhere in there was a problem with that sent folder, and they could not see their sent folders.
Oh.
So there were some really big issues, and no one had a correction or anything for it. So
I see. Okay, well, we'll talk about it when we get to this point. What do you think web browsing has to do with security of a system?
a lot.
It's a client-side thing. I mean, you're not, someone cannot attack you actively when you are doing web browsing. But what can happen instead?
You can click on something in one of those web browsers.
You can
and it
step
might-
on something. Yes, you don't even have to click sometimes. You can just step on something and your system gets infected. Okay? In Windows, there was a time when you can look at a picture, just a regular JPEG, and your system can get infected. Do you guys still remember that bug?
I remember that.
Was it a GDI library related bug?
I think
I think it was a GDI library kind of bug. How did it happen? How can something like this happen? In other words, you can go to, let's say, eBay or Craigslist, okay, and look at a picture of a, I don't know, a lawnmower, okay? Look at the lawnmower, picture of a lawnmower, and then your system can get infected.
Well, your system downloads everything that you see into your RAM and
Uh-huh.
basically says, okay, I'm going to keep that so that I can review it later in case you go back to it again.
Okay.
So it's actually installed it on the RAM. Now, on the RAM, if it's got certain functions in the background, such as an executable of some sort, it will obviously.
But how can a JPEG, a picture, be problematic? I can understand Office documents because they can have VB scripting, and VB scripting is their programs. When you double click on a document, certain VB scripts can run automatically. Okay, so that can be a problem. I can understand that.
They usually put the binary code for the program inside the JPEG, and then usually it's like the JPEG viewer or whatever that pulls it in and has a
Mhm.
vulnerability where it's going to execute that code.
Yep.
That should.
But how can a JPEG has executable code? They're actually exploiting one of the fields of a JPEG. When you look at the format of a JPEG, it's supposed to allow comments or something that you can type, but the field was supposed to limit it to like 256 characters or some really limited number of characters. The hackers found out that in Microsoft Windows, certain versions, the limitation of 256 characters was not checked. It was not respected. So what they do is they make the payload larger than 256 intentionally. And because Windows did not check the actual length of that particular field, it was only looking for a 0 byte or null byte to stop looking. So all the other bytes beyond 256 will get into a place where you're not supposed to overwrite.
It's a buffer
Okay?
overflow.
It's a buffer overflow kind of deal. And they figure out, how to exploit that buffer overflow weakness and be able to put a payload into a JPEG so that it will purposely overwrite certain contents with certain specific contents. And then when the function, this is in the programming concept, when the function returns, it will actually start to execute the code that overwrote a part of the buffer that it's not supposed to. And therefore allowing the payload of a JPEG, the malware payload of a JPEG, to gain control at that point. And because apparently that part is running at with elevated privileges, so that means when it does run, it can hack into the system pretty bad. And it was a GDI bug. Nobody expected that, but it happened.
Well, that's what hackers look for, is things that people aren't paying attention to.
Okay, here's a question. It's kind of related to Linux, but not. Would that work on a Linux system? The same bug, the same exploit. Very unlikely. Okay, exploits that are intended for Windows rely on features of Windows. So even though it is the same processor, an i386 processor, if a particular virus or malware is targeting Windows, it is very unlikely that it will work in a Linux system. It just won't run. It just will not run because the standard of how a Linux program talks to the kernel is different from how a Windows program talks to the anti-kernel. So that is just completely different, and it just won't work.
Now Mac, what about viruses designed for Mac and Unix in general?
It won't work. It won't work cross system.
Okay, yeah,
Yep.
specific for.
But there are things that will work cross system.
But Java. Java.
Java will work across system. JavaScript also will work across systems. And that's what you need to watch out for when we're dealing with web browsers. Firefox is Firefox. So when you run Firefox on Windows, when you run Firefox on a Mac, and you run Firefox on Linux, it is still Firefox. So if the JavaScript engine of Firefox has a problem, it will be the same problem across all the platforms. What kind of problems are we expecting? This is kind of outside of the scope of Linux because it's actually inside the browser, has nothing to do with the operating system. What kind of bad things can happen with a browser that can lead to security issues?
Executables.
Nah, executable I'm not too worried about, because executables intended for Windows won't run in Linux. So I'm not too concerned about that.
Plugins?
Plugins can be a problem, but most of the time you get a little pop-up to say that do you want to install this plugin? How about leaking cookies? Okay, what am I talking about here? Leaking cookies.
Websites are able to access other websites' cookies. Is that
Yep.
right?
Why would that be a problem?
Personal information.
Well, not so much personal information, but they can try to hijack your session. Okay. Now this is kind of beyond the scope of an operating system class because it has to do with browsers and how cookies are used when you browse the web. Okay, let's see if I can illustrate it. Okay, let's say I'm going to wellsfargo.com. Okay, and when I go to wellsfargo.com, I have to use my username and my password to authenticate to get into the system, right? Now, after I get into the system, how do you think Wells Fargo can keep track of the quote-unquote session?
With the cookies.
Through cookies, right? It will install certain cookies on my browser to identify, okay, this is an authenticated session, and the cookie will also help to identify who I am, so when I pay my bills and check my balance and stuff like that, it automatically knows who I am and which account I'm using. Because without a cookie, it will have to ask those questions every time you click. Okay, because TCP/IP, every click on a browser is at least one individual TCP/IP connection using HTTP. And when your browser renders stuff, okay, that means that session, that communication is over, the connection is over. So it relies on cookies to establish your identity, your active session, that you are authenticated, and so on and so forth. Are we doing okay so far? So Wells Fargo, the server of Wells Fargo will give me a token, and it's a lot. If you look at it, it's just a whole lot of gibberish, but it does mean something to the Wells Fargo computer. What if I take that cookie and replicate that cookie on a different computer so that I can try to make the other computer pretend to be this user with this authenticated session with Wells Fargo? Now, fortunately, it does not work. Because if it does work, we have a big security issue. It doesn't work only because of one thing. It's because Wells Fargo also checks the IP address.
But you can clone an IP address.
Not so sure about that. But if it comes from the same household, there will still be a problem.
Right.
Because you're going through the same residential gateway, so that means from Wells Fargo's perspective, it's still the same IP address. So
Well, and I think it would give one or both say, hey, there's multiple people on here, re-log in anyway, won't it?
no, it doesn't know. Remember, the hijack is intentional. Somebody is intentionally trying to hijack my session. Okay? If the hijacking computer is running from the same subnet that is going through a residential gateway before going out to Wells Fargo cannot differentiate that there are two computers behind the firewall.
So they don't see a MAC address.
It cannot see the MAC address. Cannot see the MAC address because the MAC address can never get past the local subnet. Okay? So I can still have a problem because what if one of my neighbors hacked into my Wi-Fi network? That can still be a problem.
Right.
How
You
many
still
people
see
are still running web? Wireless equivalent, no, wired equivalent protection. I hope nobody is still using it. How many bits of encryption are we talking about with web?
8 bits. 8 or 12.
At the most 128. Okay? How long would it take to hack or acquire a web key?
Takes me 5 minutes. Takes me 5 minutes.
It takes you 5 minutes?
I got 8 cores.
But doesn't that depend on the amount of traffic too?
Right, but
Well, and if you have a rainbow table, it'll make that even less.
I was using Backtrack and I was using
So you have a log to begin with.
so I had
Okay.
some stuff to
Yep.
check out my test wireless.
But doesn't that tell you something? I mean, if you're still running web at home, you might as well just make it open and gain some efficiency.
Yeah.
What if you're checking your bank account balance at Starbucks?
Never good.
Well, ideally speaking, it's okay because it uses HTTPS instead of HTTP. So we are encrypting end to end. The encryption is from your computer all the way to the Wells Fargo computer. So even though the Wi-Fi is open, the traffic is encrypted.
Well, they could put a man in the middle of faking the hotspot and linking between the hotspot and your computer between them.
Well, that's when your browser will pop up a big page and say, something bad is going on. Are you sure you want to proceed, right?
And most people, like, the schmucks that they are, would just say, oh, yes, I want to go there.
I don't know about that.
I do it all the time with the ARC hotspot.
Yeah.
Yeah.
Confirm security exception.
Yeah.
If you go to school here long enough, you learn to just, confirm.
Yep.
Yeah, I was curious, why are some companies, when I say cable companies,
Mhm.
handing out web? WEP?
Because they have 20,000 of those units still sitting in a warehouse.
That's
I don't
what I
know.
think
I don't know why they're still using it.
Kind of.
I think that changed a while ago.
Okay.
I know
Sure,
the
what?
DSL modems have changed a lot over the years.
Mhm.
I know I just recently got a new modem router from Sure West, and I've got it's a pretty nice high-end modem router that they put in.
But there is a good reason why you may not want to do online banking at Starbucks or some place like that, because they don't really need sophisticated way to hack into your system. All they have to do is to look over your shoulder
Stand behind you.
with a camcorder. Okay. Now, how do you know someone is using a camcorder to record?
You don't always.
Red lights.
Don't. You don't, because if you go to like spycamera.com or whatever, they have cameras that are so small with low lights, light with sensitivity, so it can be a visor type, and the camera is right here. It will just record everything that the person is looking at. Okay, and you cannot see that you are recording. You cannot actually see the camera itself. They make cameras that are so small that it resembles just a little bit of a thicker of a pen, and someone can put it in a pocket, and they can walk around and record everything. Okay.
Even smaller than that.
So we are talking about security way beyond what Linux that has to do with Linux, but it's still stuff that we have to
There's
kind of
also
talk about.
one company I worked with had basically an audio recording keylogger,
Mm-hmm.
and basically they can tell what you're typing just by the sounds the different keys make on the keyboard.
Yeah, I heard about that. It only worked on Apple iPhone 4S.
No, it worked on
3S,
standard.
4?
It worked on basically just on any keyboard.
Yeah.
The one thing that messed it up is we had one guy on a Dvorak keyboard, so like a part looked like a JAPL or something, whatever
Mhm.
the key equivalent is on the Dvorak keyboard. But
They can just remap the keys. They can I think that's not a difficult problem to deal with.
Sounds like
From
old
the
red
hackers.
boxes.
Hmm?
It says sound like the old red boxes.
The old.
Old red boxes. And red boxes record the telephone tone so that we can go to a payphone and have free phone calls forever.
No,
And
that's
then go on
before my
British
time.
from Canada. No, you don't
that
know
was anarchist cookbook days.
Okay. Okay, topic 6 is important. Apply client-side file sharing security and file system permissions for users and groups to ensure, not ensure, correct access to resources. Okay, now this is important. Yep.
Going back to topic 5.
Okay.
But I've noticed that at home, what kind of I don't know if this is the internet or my computer or not, but when I'm on the internet, and I'll click on the site, it'll randomly take me to another site. But I noticed that when I'm doing it on all my computers at home, it does that. Is that what is that? I know there was that virus thing that was getting spread around everywhere, where if you click something, it would take you to another site. Name server.
Okay. Now I can tell you the mechanical part of how that can happen. The first thing is check your browser that is not using a proxy server. What a proxy server is, it's a place to bounce all the outgoing traffic through when you are going to a particular website. Okay, a lot of hacks involve the use of a proxy server. So you can go to the browser settings. Okay. So let's see. This is go to settings. This is Google Chrome, but I think you can find the settings on yours. Similarly, go to advanced settings. Go to proxy settings. When running Google Chrome under supported desktop environment, the system proxy settings will be used. However, either your system is not supported or there's a problem launching the system configuration. So in this case, I don't have a proxy service running, so that's why it doesn't even display the configuration screen.
So Chrome is more secure on Linux than it is on Windows, according to that.
There is a host folder in the system that he changed. The host folder in the system.
Yep.
He changed the IP address every time he typed any website.
Uh-huh.
He changed it for it.
Yep.
And it changing the host.
Now, not only that, but when you go through a proxy server, it can be completely. It can look completely normal, but that also means whatever you do on your web browser, the proxy server knows exactly what you're doing too, because every outgoing request is bouncing through the proxy server first. So even if it's not annoying that it's going to random places, they can still keep track of your traffic, and that's a privacy issue already. But that's not a Linux thing; it's a browser thing.
So pretty much like if I want to go to Google, I'll type google.com, and then it bounces to the proxy server, and then that's where it connects me. Is that what you're saying?
Yeah, the
If
proxy
I
server is quote unquote. Now, when it's working correctly, the proxy server will make the connection to where you want to go,
Yeah.
and then give the content back to you.
Okay, so pretty much I send it to the proxy server, it gets it, and then it gives it back to me.
Correct.
And then what they're doing is they're probably messing with the proxy server. And just
That's
like,
one possibility. The other possibility, which is even more disturbing, is someone is messing with your DNS settings.
Yeah.
Now that is way more disturbing because DNS is domain name service, which is basically 411 for computers. When you say google.com, they have to find out what is the IP address corresponding to google.com before it can make the connection. If someone gets into your DNS settings and use some other server as a DNS server, when you ask for google.com, they can give you an IP address of a website that they choose. So instead of going to the actual google.com website, you'll be going to another website.
Now what I noticed is it just happens randomly.
Nothing is really random.
Well, what I mean is like one day I'll log on to it and it'll work fine.
Is it browser dependent? Does it work? Is this a symptom regardless of which browser you're using and regardless of which computer you're using?
I wouldn't know. I only use Firefox at home.
Okay, you might want to try another browser and see if it has a similar problem. If it doesn't have the same symptom, then you can probably conclude that it is a browser side issue. So maybe your browser settings, have been hacked. If different browsers behave the same way, it is possible that your computer itself is hacked. If you try different computers and they still behave the same way, that means your connection to your service provider may be hacked. The worst case is your residential gateway itself is hacked. Then you have a problem because no matter which computer you use in the house, it will still be bouncing off the same DNS, and unless you use manual setting with the DNS. So you can always force the DNS setting on your computer to 8888, which is Google's DNS server. So that hopefully will make sure that you get to the right IP address when it looks up the name. It's hard to diagnose the problem because it can be a lot of causes. Okay. Any other questions related to that one? That's an interesting one. But I'm glad I'm not having that problem.
Yeah.
My brother-in-law, who I cannot name, goes to a lot of gambling websites sometimes. Back in the past, porn and gambling are the two worst type of websites to get your system infected with all sorts of stuff. So I had the honor to have to cleanse his system of viruses, and it was interesting. It was educational.
You look at donkeys very differently now? You look at donkeys very differently now?
I guess. There were things, there were interesting bugs too. They had, I know this part is not related to Linux too, but it can happen to Linux systems too because the approach will still work regardless of the operating system. He got infected by a virus or malware. I cannot classify whether it's a virus or not. But it starts up 3 processes at the same time. And the 3 processes will monitor the existence of each other. Okay? When you know how that's going to work, right? Yeah, so when you want to run a virus checker, the virus checker can only detect one at a time, right? And it will try to kill the process one at a time. As soon as it kills one, the other 2 will notice, hey, Jack is gone. Let's respawn him. So it recreates Jack right away. Now after Jack is recreated, it's Tom's turn to get eliminated, right? But it's okay because Jack is keeping an eye on Tom. So when Tom is killed or terminated by the virus checker, guess what? Tom will instantly be reborn. So because of this relationship, no virus scanner was able to kill the malware because it keeps restarting itself because it's relying on the other two to restart the one that is killed. And then there are ones that will also kill the system as soon as it detects a virus scanner is working. Eventually, what I did was I reboot that system using Linux and then use ClamAV to cleanse the system because it's not on the system that is infected already. And that ended up killing some other files that was needed. So I had to do some repair after the fact, but I was able to remove the malware because of that. So it was nasty. Yep. Okay. Construct group and other policies on the local workstation to ensure maximum security without preventing access to necessary resources and programs. This is fun. Okay, by the time we get to this point, it's a lot of fun because Linux with extension 3, you can do about the same thing as in Windows. You can actually do a little bit of access control using group policies. And I'll give you homework assignments like, I want to make this file visible to this person and that group, but not to these people. And I'll give you a lot of restrictions like that, and you have to figure out what is the best way to set up your policies to make it happen. And in topic 8, access security issues, ethical considerations, and privacy considerations and regulations. Okay. Has anyone run into these problems? Especially with regulations or ethical considerations.
What do you mean by ethical?
Is it okay to set up a utility program to monitor what somebody else is doing on the computer? And if so, to what extent?
Yeah. That all depends on how much those people have signed their lives away to.
Well, what about at home?
At home, actually, from what I understand,
Parents.
it is you cannot monitor your kids online through a remote computer. You're not allowed to. From what I understand, it's illegal to actually do that, even though you're responsible for what they do. Legally, you're not allowed to monitor your kids.
That would be a good topic to go over when we get to topic 8, isn't it?
Yeah, I found that really. Yeah, I haven't done a whole lot of investigation on it, research on it.
What about the government? What can the government to your computer? What can the government do to your computer to monitor
without
you?
the Patriot Act.
With
or without the Patriot Act.
At this point, with the Patriot Act.
There's nothing they cannot do to your computer.
And how do they do it?
Any way they want.
I mean, you don't see police officers with a CD-ROM coming into your house and say, hey, I would like to install this program to monitor your activities on your computer, right? That doesn't happen. So how do you get your computer getting monitored by authorities?
The service provider has to do like a complete, it's called CLIA compliance, basically for data is what it is.
Mm-hmm.
So usually the service provider, like for us, we have a box that sits there. Basically, all of our internet traffic goes through it,
Mm-hmm.
and if they send us a subpoena for records, we can put an IP and shoot them all basically on workers.
But that's with a business type of establishment. But what about at home?
Well, I mean, I work for a service provider, so that's what we do.
Mm-hmm.
For let's say a government wants to know what John Doe's doing. Okay, they'll send us a subpoena that says, okay, we want the records from him.
Mm-hmm.
We can turn this on his IP address
Right.
and send all that information to him.
Yep. But the government also installs software on computers. They have their own, programs to be installed covertly on user computers.
Stuxnet.
Stuxnet is
Isn't that the one that blew up the Iran
Right.
power plants?
Yeah, but that doesn't really affect us unless you have a nuclear plant at home.
That kind of power though.
Yeah, but they don't want to waste that power on us. I mean, that's like a overkill. Go ahead.
Oh, I heard that if you have an encryption software, you have to give the government a backdoor into it so they can encrypt anything.
big businesses, I think.
That's what I had heard.
Well, this was a discussion on the other day when I talked about how to encrypt your entire hard drive. Remember that? A lot of times you cannot just tell the court, I forgot my key. That usually doesn't work well. It depends on the situation, but it's very gray. That area is very gray. Assemble and configure a network intrusion detection system. What is the most famous IDS used by Linux systems?
Snort.
Snort, exactly. So we'll use Snort, for this purpose. Set up file sharing and implement data security on the local workstation. This is one of my favorite, subject because a misconfiguration can lead to a lot of problems. Okay, I'll just give you a preview here because this is like a look ahead of what we'll be talking about. Let's just say that I have the experience of someone misconfiguring this, and what happens is when you mount a remote file system onto a local client, the file permission is inherited from the remote system and not from your local system. So that means you can try to protect the mount point all you want. Once the remote file system is mounted, the permissions of the remote file system is going to override the local permission settings. Okay? So that means whoever is setting up the remote file system has to keep in mind that this remote system or this file system may be mounted on these other systems where you cannot trust every single user on those systems. And I have the honor of working on a system where that was not considered. In other words, the remote file system or the administrator of the remote file system was thinking, hey, anyone who have access to this remote file system can be trusted. So it's not necessary to set up all the file protection. So it was wide open. When the remote file system that was wide open was mounted onto a local system, it is still wide open. So that means any person of the local system can now have access to the remote file system. It was really bad because files with social security numbers was involved. Really bad. Arrange and implement multiple user security settings for a shared workstation. A lot of these are overlapping, so I'll be combining some of these topics into one. Evaluate file system security and encryption method for a shared workstation. In other words, if you are sharing the same workstation, a PC on a client, with another user, how do you protect your stuff? Is there a way to protect your stuff? Okay. So we'll talk about this. Implement and test different encryption methods. Analyze network security fundamentals and the application to the local workstation to prevent unauthorized access. Does that sound familiar to you? Isn't that kind of what we were doing earlier today? And then there's the final exam. So basically what we are doing is we are separating these into 2 or 3 main topics. One topic has to do with from the outside, can someone get into your system? Okay? But with a client system, that is unlikely because for the most part, you're not going to respond to requests coming from outside. The second question has to do with the file system itself. Who can access which file and how, what type of access we are talking about? And that's a big topic. And then the third one has to do with intrusion detection. The third one has to do with how do you prevent your system from inviting threats into the system through web browsing or opening attachments from email and stuff like that. Before you access a file, before you run a particular program, how can you double check and make sure that this program is not infected before you open it? That's the question. ClamAV can actually do it. Okay, ClamAV or Clam Antivirus has a component called ClamFS or Clam File System, where it can sit on top of an existing file system. But if you access your file system through ClamFS, every time you open a file, it will scan it. Every time you write to the file, it will scan it. So it's an on-demand kind of thing. It doesn't do unnecessary scans in the background, but whenever you access a file, it will be scanned on the fly before the file is actually available to the application that's trying to open it. So we'll talk about that because it's really quite handy. It's a neat feature. All right. So are there any questions? I cannot give you any homework assignments at this point, because one, I didn't have time to set up any homework assignments, and two, we do not have a reliable live DVD that can work on all systems, so I cannot make any assumptions at this point. But are the concepts okay so far, or it's kind of moving a little bit fast or slow? Slow.
Perfect.
Perfect. Oh.
This is all recorded, right?
Hmm?
We can look over this again.
Yes, this, let me double check. I don't trust myself. Yep, it's still going, and the program should still be running too, because otherwise it wouldn't show up here. Yep, it's still recorded. It's still recorded. So everything will be uploaded later today, and you will have access to not only my voice, but also what's being displayed on screen at the time.
So we'll see this for the last 5 or 10 minutes.
Yep, exactly. Any other questions? No other questions? Okay. If you guys can think of any additional questions to ask, go ahead and bring it to the class or send an email to me, and I will try to integrate. If it does relate to this class, I will try to integrate it into the notes. Okay. I'll see you guys next Thursday. Have a nice weekend. If you want to stay here and just play with a live DVD and ask questions, I'll be here to answer questions. I'll just stop the recorder.